Let's talk about identifying similar polygons. Okay, so first we've got to go through a few definitions before we get started. First definition is similar figures. Similar figures have the same shape but may not be the same size. So for example, this triangle and this triangle are similar. They're both shaped the same, but one's smaller than the other. So we could say that they are similar. Congruent angles are angles that have the same measure. So if I drew this angle and I said that it was 100 degrees, and then if I drew this angle and I said that it was 100 degrees, these two angles are congruent. Okay? So we have two symbols that we need to know. This symbol, oops, I wrote that one wrong. Just realized I wrote that one wrong. This symbol means is similar to. And this symbol, the equal sign with the squiggle above it, means is congruent to. We're going to use those quite a bit, so you will get comfortable with them. But that's what those two symbols mean, so you can pause and write this down in your notes so that you will have this to refer to later. So similar figures, same shape, but might not be the same size. Congruent angles have exactly equal measures. One squiggly line means is similar to. Equal sign with a squiggle above it means is congruent to. Okay? Then similar polygons. Polygons are closed shapes with straight lines. So similar polygons have corresponding angles are congruent, and the lengths of the corresponding sides form a proportion. Those are the two tests to see whether you have a two similar polygons, because that's what we're talking about today. So this is what we're going to focus on, is looking at two shapes and deciding, are their corresponding angles congruent, and do the lengths of their corresponding sides form a proportion. So let me show you how we're going to do that. I have these two shapes here. Okay, two rectangles. This we would call rectangle LMNO. Okay, and this we would call rectangle HIJK. Notice that when I named them, I went in the same order. Since I did L first and I kind of went here, 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 here. When I wrote down this rectangle, because really I could start anywhere with my letters, but since I did the upper left first with this rectangle and I went around this way with the letters, I want to do the same thing with this rectangle, so I call it HIJK. The question is, are they similar? Can I put this little squiggly line in between those two figures? Well, let's talk about that. First thing, their corresponding angles have to be congruent. Well, let's look at that. Corresponding angles are the angles that are kind of in the same spots on the two figures. So I have angle L here. Which angle over here matches with angle L? Well, it's going to be angle H. Do they have the same measure? Yes, they're both 90 degrees. So I could say that angle L is congruent to angle H. Okay? Let's check angle M. Its corresponding angle is going to be in the same spot on this rectangle. It's angle I. So angle M, they're both 90 degrees, so angle M is congruent to angle I. If I look at angle N and then angle J, they are congruent. Angle N is congruent to angle J. And then finally angle O, and the angle that corresponds to it, it's in the same spot on this rectangle, is angle K. And angle K is congruent, I should have started with O, sorry. Angle O is congruent to angle K. So the first test of whether or not these two shapes are similar is, are their corresponding angles congruent? Well, yes, I just proved that all four of them are. So far we're on track. Now let's talk about whether the lengths of corresponding sides form a proportion, okay? So with a proportion, we need to make sure that we put the corresponding sides in the same ratio. So let me show you what I mean by that. Let's look at this number 10 right here. I'm going to use this rectangle on the top of my first ratio. Okay, which side over here corresponds to the 10? It's the 8. So the 8 is going to go on the bottom, and I'm going to set that as being equal to. Now for my second ratio, I'm going to come back over here. My other side length is 4, and since I put 10 on the top of this ratio, I have to put 4 on the top of this ratio, because it's kind of like I'm using this rectangle for the top numbers and this rectangle for the bottom numbers. Okay, so here's 3 corresponds with 4. Those are in the same spot, and so I'm going to put that there. So this is how we are testing whether the lengths of corresponding sides form a proportion. I set it up, and my question is, do those equal each other? So I need to do some cross multiplying. Totally forgot to grab my calculator. I could do it without my calculator, but I'm going to grab it so I have it for later. So I'm going to cross multiply numerators times denominators. 10 times 3, and I'm going to see, does that equal 4 times 8? Well, 10 times 3 is 30. 4 times 8 is 32. They do not equal each other. So, no, these two rectangles are not similar polygons. So the answer is no. The reason why? Their corresponding sides do not form a proportion. If these two numbers equaled each other, then yes, they would be similar polygons. So your steps here are to draw the pictures, decide whether the angles are congruent, and then do a proportion to see if the side lengths are congruent. So you're going to do that now with an example problem, okay? And if you need to rewind and watch this again, then do that. But you're going to look at this problem here. Rectangle EFGH has side lengths of 18 and 27. Rectangle LMNO has side lengths of 36 and 54. Are the rectangles similar? So I want you to pause the video and work on this problem and then restart it to check your work. The first thing you should always do is draw a picture, okay? So pause the video, draw your picture, and do the work, and then restart it to check. Okay, so I'm going to draw triangle EFGH. EFGH. I know since it's a rectangle, they're all going to be 90 degrees. It has side lengths of 18 and 27. LMNO. I don't have to draw a perfect rectangle. I do need to put the letters in the right spot. Since I started with E here, I have to start with L in the same spot on this rectangle. And it has side lengths of 36 and 54. So now I need to decide whether or not they're similar. Okay. First test, are the corresponding angles congruent? Well, yes, they all are, because angle E is 90 degrees. Its corresponding angle, angle L, is 90 degrees. Angle F is 90 degrees. Its corresponding angle, angle M, is also 90 degrees. Angle G, 90 degrees. Its corresponding angle, also 90 degrees. Angle H is 90 degrees. Angle O is also 90 degrees. Okay, so I could write it out. Angle E is congruent to angle L. Angle F is congruent to angle M. Angle G is congruent to angle N, and angle H is congruent to angle O. So now I need to do my proportion. So I'm going to do the side lengths. 27 is going to go on the top. The side length that corresponds with it is this 54, so that's going to go on the bottom. Then I'm going to go back to this rectangle, 18 is going to go on the top because I have to be consistent. Since I use this rectangle on the top, I've got to use this rectangle on the top of the second ratio. The side length that corresponds with 18 is 36, so that's going to go on the bottom. And then I'm going to cross multiply. I'm going to do 27 times 18 and see if that equals, or 27 times 36 rather, sorry. And I'm going to see if that corresponds to 18 times 54. So 27 times 36 is 972. 18 times 54 is 972. So yes, these two figures are similar because their corresponding angles are congruent and because their side lengths form a proportion.